So first, let's continue of where we left off. And here's sensors in FPC. So the distance, please mute unless you're asking a question. Then you can type in the chat. Distance sensor sends out an output, a signal, or like it could be infrared, ultrasonic, lasers, and then pretty much intakes it and sees the timing it takes for it to reflect. The Rev2 meters distance sensor uses measures up to 2 distance. So for people who don't understand, it senses, let's say, a radio frequency. It hits like, let's say, an object and reflects back, and it measures the time it takes to do so. So it has this formula inside of the sensor where it can calculate the distance depending on how much time it takes. So distance sensor can be used to identify objects. It can also be used to figure out the distance, so it can perfectly stop a certain distance from the wall. However, it can be slightly inaccurate for not perfectly smooth objects. The color sensor uses a built-in IR proximity sensor and white LED to activate target lighting. The sensor detects light reflected black from detected objects, and pretty much based on the color, but please don't annotate. It makes it slows down everyone. Okay, so let's continue. Okay, so the color sensor can be used to see a certain color, like a tape, or it could be used to detect an object of a certain color, or it could just be used to check if something is of one color. So potentiometer is pretty much an analog sensor, which up to 270 degrees, it can pretty much convert an angular position of a shaft to like a voltage signal. So it detects pretty much the rotation that has occurred in a mechanism. So it can be used to limit how much an axle rotates. If it's a robot arm, can rotate it till 90 degrees, then stop, for example. It's more accurate if you do it by time. And of course, it can be used as voltage dividers and audio control as well. Now the tough sensor. So it's pretty much like a button with an LED. So pretty much if the button is not pressed, LED is not lit and has a high voltage. If it's pressed, then the LED is lit with a low voltage. So this is best input. This is best for input and for user input, and can be used as a limit switch. So, for example, humans can use this to start the robot. It can also be used to see if how much the mechanism wants to rotate down. And if the arm touches the switch, then it stops the rotation and can sense whether the robot hits something. And again, if you don't understand something or you have to ask a question, just type in the chat and I'll go over it. The limit switch is, it looks like this. So all the sensors looks like the image on the right. And pretty much there's triggers on the top and on the sides. Any of them can be triggered. It detects magnetic fields, and it's a lot more triggerable touch switch, pretty much. So it's very trigger happy. And it's best to use for user input. And again, similar to this one, it could be used as touch sensor application. So everything applied to here is more or less applied to here, but can also be used as for controlling machinery. And for example, it limits the robot arm from going past. And it can be used to count objects that touch it. So the Rev Blinken LED driver. So this is a compact LED driver the LED driver that controls 12V RGB LED and 5 LED strips. So combined, it has a 5 voltage power source, and it has a pre-programmed controller, and has a pulse control color patterns. But it's not really a sensor, but it's still it's important as it can be used in many scenarios. For example, it can be used in FTC challenge to have lights display around the robot in autonomous teleopera endgame. And sometimes things are very hard to see in the robot if it's in the middle. But using this, you can send signals for everyone, for like the drivers on the outside to see and understand what's happening inside the robot. For example, let's say there's like, as in the container, if there's holding 2 rings, then it can have an orange light around it. If it's 1, it could be green, 3, red. So it could show different colors for different actions. So next, I want to cover the Roadrunner odometry system. Odometers and roadrunners. So most robots, of course, not all, but a lot of them, use 3 odometers to find the horizontal and vertical positioning on the robot on the field. And it can also be used to figure out the robot's direction. The control hub determines the coordinates of the current location. As you probably learned in the previous days, the control hub is pretty much the brain of the robot, as you might say, and also dictates the contact of where the driver has control over the robot. The odometer converts the field into coordinate grids, which can be used to return the current location of the robot on the field. So it's pretty much a motion planning library, Roadrunner, that is used in FTC competitions. It could be used for automatic movement and path generation for robots. It could be used with odometers, which makes it very useful. And the Roadrunner library is FTC SDK, and you can use the odometers to create autogen paths to specific locations. So this is Roadrunner in action. So as you can see, this is autonomous. Pretty much the drivers don't control. As you can see, there's nothing over here. The robot's doing all its own, and it's already figured out where it is on the field and where to go next. Okay, what? So understanding localization and positioning. Localization is the ability of the robot to figure out where it is at any time. So it's used using odometry usually. There is other methods, such as the VSLAM or T265 camera. And it's pretty much used to feed information into the respective equations to create an approximate XY coordinate of the robot on the field. So vector 2D is pretty much an XY coordinate. Vector 2D, my vector, is pretty much a new vector. And opposed 2D is a heading, includes a heading. So, for example, over here, it wants to go to a certain point and within the radius of a circle of 90 meters. However, the main difference is that the heading, because they want it to be in a specific heading, which is the reason it's different from here. Open loop versus closed loop control. Open loop estimates voltage needed to power a motor. Now, this is too accurate and does not adjust for real-world problems that reduce motor speed and physical tolerances. So a closed loop uses feedback from the motor to adjust the voltage. If the motor is given some voltage, but it's too slow, more voltage will be given. This is done through the PID, a proportional integral derivative, controller, and the use of motor and encoder. And remember the motor encoder we discussed last week. At the end of the session, if we have time, I will discuss it. And We should ideally use closed loop control, but open loop is easier to set up. Controlling the robot. So you need to understand how the robot's controlled through the driver station and the rev hub, which again is the brain. So the rev control hub has a lot of cables and port cables and can be used to control, again, inbuilt controller. Does not need a driver station phone. And includes 4 DC motors and encoder ports plus 6 servo motor ports plus power, 4 analog, 8 digital, and 4 I2C ports for sensors and an inbuilt IMU for heading, and 2 RF485 ports to connect to another expansion hub. So this is the expansion hub. So it comes with 4 DC motor plus encoder ports, so similar, but also with 6 servo motor ports, power, 4 analog, 8 digital, 4 2IC, and so look, pretty much the main difference between this and this is it must connect to a phone. However, this does not. Expansion hub. So pretty much how it works is there's a communication cable and there's the extension cable. So pretty much allow them to, well, what you would consider in the robot world, to talk to each other or calibrate logarithms with each other. So for example, if there's like a sensor coming from expansion hub 2, and there's like another motor from expansion hub 1, they could be like, oh, I saw that this object is 10 meters away. And this would be like, okay, I will stop in 10 seconds or something like that, which can only be communicated through the communication cable and extension cable. So I'm going to wait over here and you guys can look at the reference sheet. And if you want, again, ask questions in the chat or take notes. So controlling the expansion hub helps controlling the robot, as it's pretty much like a wireless control system. For example, the expansion hub has pretty much like, for example, has access to the sensors, the motors, and everything else. We don't have that exactly, right? We can't say like, oh, the sensor is like this, right? That's what the expansion hub does. The expansion hub pretty much calibrates, for example, if there's like a distance sensor, it figures out, okay, that object's 200 meters away from me. The expansion hub is like, okay, that means I'll reach there in like 30 seconds or something like that, right? So it's pretty much all the brain work, and then therefore, so not now it understands how much distance, right? Then it can be like it sends a signal to a motor. You go 10 more seconds and stop, right? So like that. So I'm wait like 5 more minutes, then we'll go on. Okay, so pretty much the difference between the coding and programming is, okay, coding is pretty much external. Think of programming as they're pretty much very similar and very much the same. However, programming, let's say a motor, would be more like tuning it. Coding a motor is telling instructions. For example, programming would be like, okay, so making sure the measurements are correct, but coding is like getting the measurements itself. And how you send coding programs to a robot is you have to download it through the Rev expansion hub. So that's another reason why it's super important. So without a Rev expansion hub, you can't have a robot. Like, you can't have an FTC or FRC or first robot as a whole. So what computer program do people use to write code? You can use Java, Python, HTML, and code is essential to robots, even if you put sensors. Because thing is, sensors need code too, right? Sensors are just material and objects if you don't put code in them. Code is what makes them get the signals, get the measurements, and give it back. So that code, a sensor is useless. It's just an object. So RevHubs both are used to control the robot. Use Java programming with Java programming language with FTC programming library. So now we're just gonna watch this. Can you type in the chat if you can hear it? Can you guys hear it? You can just unmute or you couldn't. Okay. Can you hear it now? Not even now? Okay. Okay. One thing, so I'm gonna send you the YouTube link so you guys can watch it right now. Okay, just give me a moment. So in the chat, I sent a link. Please watch it. That should take around 5 minutes, but giving me the benefit of the doubt, I'll give you guys till 9:45 to watch. Okay, so guys, if you want the recording for yesterday's session and today's session, so go to our YouTube channel, Ink and Metal, and there it will be there. It's already posted. So go to Ink and Metal 5773 so you can look at the recording for both today and tomorrow and the previous sessions. And there's other stuff too. Like, see, this is a crash course. This is a crash course 11. There's up to, I think, there's a lot of crash courses over there, more than 30, I believe. And there's other videos too that you might find interesting. Okay, now let's go on back to our presentation. It's an Android Studio. It's a downloaded IDE, which is a short name for code editor, to write Java programs to control the robot. So Ink and Metal as a team, we prefer to use Java. However, there is other teams that do other programs. So don't feel restrained if you want to do FTC to only do Java, or to only do like Java. You can do anything that suits you. However, Java programs are easier to download with Roadrunner software and can download a project template with FTC libraries, and you can upload code to the Rev Control App or the Driver Station fund, depending which one you use. So look, this is pretty much how it look like if you use an Android phone, or like on the Android phone, you connect to a Rev Control App. We're using own Android phone to run remotely. We're using the Rev expansion app and driver station. Use only one Android phone for the driver station and an Android phone to code remotely. So this is how the remote controllers would look like plugged into an Android phone. It shows the functions of our controllers. Again, I'm just giving you guys like 5 minutes to look at it. So let's move on. So these are the awards of FTC. First is the Control Award, which, I mean, it pretty much means what the title is. And you already talked about it, but pretty much it means like as Control Award is, again, how much control over the robot you have. Pretty simple. The Rev Hubs shows the weakness. We show the weaknesses, strengths, and weaknesses of different Rev Hubs. Talked about Android Studio and activity designed robot based. So this is what we're going to try to do right now, right? So the time to think about a way to move a foundation in like a robot way, you can just talk about it, just give a paragraph about something that could stack blocks, move foundation, and fit in an 18-inch cube. Just think about it and just type in the chat what you think. Okay, but so this is something that's more offline. So just think about it on your own. This is more of a practice type of thing. So we won't be able to check it. It'll be able to help improve your own skills and help you just think about it, right? So again, this will be in a recording. And so if you want to check it out, go to Ink and Metal 5773 YouTube channel, and then yesterday's and today's will be there, and a ton of other videos that might be interesting to you. So see you and bye.